Since binary bits which have a value of 0 or 1 are usually grouped within the computer as a byte consisting of 8 bits, let's start our algorithm for converting from decimal to binary by creating 8 blanks to represent each of the bits in an 8-bit byte. Okay, next what we're going to do is, starting from the right side, the right blank, we're going to work left, showing each blank what its decimal value is. 1, 2, 4, 8, 16, 32, 64, and 128. Notice that all I did was simply doubled the value of each blank as I move from the right to the left. Now, why are these numbers assigned to each of these blanks? Well, again, it's because binary, which literally means 2 parts, is a base 2 numbering system. So each blank or place value of a 8-bit binary number is using the base of 2 raised to some power starting with 0. So 2 to the 0 power is equal to a decimal 1. 2 to the 1 power is equal to a decimal 2. 2 to the 2nd power is equal to a decimal 4. So on until we get to 2 to the 7th power, which is the last place value in the binary number, and 2 to the 7th power is equal to a value of 128. It's not important that you actually understand this whole concept of base 2 being raised to a power. Really all it matters is that you remember that starting from the right, you have a 1, and then double it to be a 2, double it to be a 4. For the next place value, it's an 8, a 16, a 32, a 64, 128. And this, of course, is for an 8-bit binary number referred to as a byte. So let's go ahead and make a conversion here. We want to convert the decimal number of 114. So what we're going to do is simply ask the question, starting with the largest number in our pattern, which is 128, can we subtract 128 from 114? In this case, we can't have negative numbers, so the answer is no. So we place a 0 in the place value for 128 of our binary number. Next, we ask the question, will 64 go into 114? Yes, we can subtract 64. So we place a 1 in bit 64, and we subtract 64 from our 114 value. We end up with a value of 50. The next place value in the binary number is 32. Can we subtract 32 from what's left? Yes, we can. 32 from 50 is going to be 18. So we placed a 1 in the 32 spot. We subtracted 32 from 50. Now we have 18. We ask the question, does 16 go into 18? No. So we place a 0. I'm sorry, yes. So we place a 1 in the 16th place, and we subtract 16 from 18. We get a value of 2. So continuing on, will 8 go into 2? No. So we put a 0 in the 8th spot. Will 4 go into 2? No. So we put a 0 in the 4th spot. And then finally, will 2 go into 2? And the answer, of course, is yes. We subtract 2 from 2. We get a value of 0. And our last place value is 1. Can we subtract 1 from 0? No. So we place a 0 in that location. So at the end, when we've converted 114 to binary, we have a pattern of reading from the right to the left, the left to the right, 0, 1, 1, 1, 0, 0, 1, 0. So let's try this one more time. Let's convert the number. Well, let's start off by putting in our blanks, 1, 2, 3, 4, 5, 6, 7, and 8. And then put the place value for each blank, 1, 2, 4, 8, 16, 32, 64, and 128. And let's convert the number of decimal 54. So again, we start off asking the question, will 128 go into 54? No. So we place a 0 in that place value of the binary number. Will 64 go into 54? Of course, no. So we place a 0 into its place value. Will 32? Yes. So we subtract 32 from 54 and we get a value of 22. Can we subtract 16? Yes. So we place a 1 in the 16's place and we subtract 16 from 22. 8 cannot be subtracted from the remainder, that's 6. So we place a 0 in its location. 4 can be, so we place a 1 and subtract 4 from 6 to get 2. And then 2 can be subtracted from 2, so we place a 1 in the 2's place, subtract 2, we end up with a value of 0. 1 cannot be subtracted from 0, so we place a 0 in the 1's place. So converting the decimal value of 54 to binary, we end up with a pattern of 0, 0, 1, 1, 0, 1, 1, 0.